In this example, we're going to look at some integration, right? It says use a definite integral to estimate the area between the curves y equals x squared plus 1 and y equals x minus 2 for negative 1.5 less than or equal to x less than or equal to 3.2. The thing that is always going to be useful or helpful here is for you to graph your function. So I did this on the computer since I don't have a calculator on my computer. So I graphed my function and my x values, I know that x's are down here. The program I use put the x values at the bottom of the graph. But I graphed it from negative 2 to 4, even though it asked me to go from negative 1.5 to 3. I wanted some wiggle room. And so that I can get a good representative picture, I went from negative 10 to 10, which is sort of standard on your calculator, right? As you can see, if you graph this on your calculator, this function right here is y equals x squared plus 1. And this function right here is y equals x minus 6. Remember that when we want to get the area between two curves, there are a couple of things that can happen. Sometimes your curve can intersect. Like the one in class, we had an example that looked something like this, where if you wanted to find the area between the curves, you have to do the integral over this area right here, and you got to be able to find these 2 points that enclose that area, right? In this example, we don't have that situation going on, all right? These curves do not intersect on the interval from negative 1.5 to 3.2. So when that happens, when we want to find the area between the two curves, the area is going to equal, and that is a mess, the top function minus the bottom function, as we've always done, right? So I'm going to have the area is going to be the integral from negative 1.5 to 3.2, because that's the interval they give me, of my top function minus my bottom function. Now, you may be hesitant to do that integral, right? Negative 1 is here, 1.2, 1.5 is slightly here. Okay, and then 3 is here, so 3.2 is maybe there. So our goal is to find this area right here between these two curves. And so we're going to use this right here, top minus bottom. So it's going to equal the integral from negative 1.5 to 3.2. My function that's on top is x squared plus 1. And my function that's on bottom is x minus 6. Notice I'm using brackets and parentheses. Again, it doesn't matter. They're grouping symbols, so they don't mean anything special here, okay? They don't mean anything special. When I do this integral here, I can put it in my calculator. This is sort of one that is sort of, it doesn't require you to put it in the calculator. But I'm going to simplify these expressions here, right? I have x squared plus 1. That's a minus x, and this is going to end up being a plus 6. So I'm going to have an x squared minus x, and then I have a 1 plus 6, which is plus 7. And if I enter that into my calculator, I'm going to get an approximation. It's going to be approximately 40.953. All right. Now this example, I know that you may be a little hesitant to get this integral here. Basically, I know in class we said that when the area, the integral between the x-axis and a curve that's completely under the x-axis is a negative area. All right, when we do the integral. But what we're doing is we're subtracting off that negative area. And so we're actually going to get the actual total area between these curves here, right? So you don't really have to worry about that positive negative thing if you do top minus bottom, all right? Now, the next example is actually an example from your homework, all right? It's section 5.3, question 3, all right? Now, this doesn't ask you to find the area between two curves. It asks you to find the total area between the x-axis and this curve right here. All right, you can think of the x-axis as a curve, even though it's really not one, but there you go. Okay. Now, there's a difference between uh, in class, I wrote an example at the end of class yesterday that asks you to find a definite integral or the area under the curve, something like this, from, let's say, 0 to 6. And I was trying to get at this example in class, but I didn't word the example exactly like the homework did, right? The homework asks for total area. That's totally different from what you will get here. If I do this integral, all right, this is going to give me, all right, this is the picture, right? This is the 16 minus x squared curve. My integral is going from 0 to 6. However, I graph from -2 to like 7, just to give me some wiggle room so I can see the graph. And from -10 to 10, I didn't get a full picture, so I went from -20 to 20 to give me a better view, right? If I do this integral right here, what it's going to do is it's going to do this area here from 0 to whatever this point here is, and we're going to find this point. And then it's going to do the area here, that's 6. But if I call this top area, for instance, A1, and this bottom area here, A2, what this integral does is it does A1 minus A2. And that does not equal the total area, because it's taking away the area A2, which is here. When it asks for total area, it does not want you to take away the A2 here. It wants you to do A1 plus A2, and that'll give you the total area. Okay? So what we'll have to do in this example is we'll have to figure out, okay, well, I need to be able to find the area A1 here, and then I need to find the area A2. And if I do an integral and it gives me a negative, I need to make this area A2 positive so that I can get the total area actually covered. All right? And so one thing that we're going to need here is we're going to need to be able to find, I want a good color. We need to be able to find this point here because it is a point that separates these two regions. And more specifically, this point right here is a horizontal intercept. So this is like a review for your final exam. We went over how to find a horizontal intercept like the first day of class or the second day of class, right? This point is going to have, and all horizontal asymptotes are going to have a y-coordinate of 0. Y equals 0 at every horizontal asymptote. So if I want to find that, I set y equals 0 and solve this equation. I'm going to do it right here. I'm going to add x squared to both sides. Take the square root of both sides. Remember, when we take the square root of x squared, we put on the plus or minus, and we get plus or minus 4. Now that -4 is probably somewhere over here on the graph, which I'm not worried about. I'm worried about this one right here, which is 4. So I know that this point right here is 4. So what I'm going to do is I'm going to find the total area, and it's going to be area A1 plus area A2. All right, and I can't use this integral here because it's going to do A1 minus A2. All right, the area corresponding to A1 is the integral from 0 to 4. All right, I'm going from 0 to 4 here of my function 16 minus x squared dx. All right, I'm going to close it there. Now, if I do the integral, now I'm going from 4 to the end point of this region here, which is 6, which they give me here as well. So it's going to be from 4 to 6 of 16 minus x squared dx. But when I do that, since it's below the x-axis, it's going to give me a negative. So instead of accepting that negative that it gives, it's going to automatically give me, I'm going to subtract that off, because when I subtract the negative, it's going to give me the positive. Okay? And so when I do that and put it in my calculator, I'm going to get that the total area here is approximately, well, it actually equals 61.3 repeating. If I round that to 3 decimal places, 61.333. Okay? So this word here is, this term, total area, won't allow us to do the integral that way. All right? We have to consider what this integration does, and so we have to separate it and actually subtract off the negative so that we can get the positive in order to get the total area. Now, if I just ask you for the area or the integral, then this would be fine. But if I want the total area, then I want to see something like that. All right, I hope that's helpful, especially for your homework. You probably won't see anything like that on your test, but there's a homework problem just like that. I hope that helps. And that's it for the review. Remember, you can send me an email or whatever, and if you have any questions.